Wait for it. Nope, that was not what I wanted to do. I think I've got wrong screens. Give me a second. Ah, classic Sasha. Give me a second. Sorry. Oh, so organized. Here we go. It's happening. It's happening. Happening. Still happening. All right. I think it's happened. Yes. Success. Okay, can you guys hear me? Amazing. Okay, that would have been really creepy as I was like just a voice without a body trying to do stuff. All right, welcome back. Week 9, last lecture in week 9, only one more lecture to go after this. I mean, you guys have almost made it. You've almost cooked to perfection. So well done on all the cooking. Good stuff. Now, I have 2 things that I wanted to talk about quickly. So one of those things is I've got lots of exam style questions, which we're going to do today. We're just going to keep doing different types of questions. We'll diagram them and then we'll draw them out and we'll basically do a lot of practice. Maybe we'll focus a little bit on linked lists today or arrays, and that's one of the questions. So that's what I wanted to poll. I forgot my question. You see, I got so into the music, I forgot what I was doing. So I'm going to run a poll with what we want to focus on. Focus of today, we've got linked lists, arrays, strings. We'll start with those three, and then we'll kind of take it from there, and then I'll do a little bit next week. And then next week we'll do a little Ask Me Anything session where we'll have 30 minutes of the last lecture where some of the admins and some of the senior tutors will come along to this online lecture, unfortunately, and we'll basically just, you'll be able to ask them anything about, you know, course progression or what courses you should do or what their experience has been, which is sometimes really useful when you're in that first computing course and want to know what happens next. I hope you have all so far enjoyed the first computing course. And then we'll kind of take it from there. Okay. All right. How are the feels? Is everyone feeling good in week 9? Assignment going well? Because if so, we shall commence. So we want linked list is like the top thing. I've realized, my experience, yes, Bree, thank you. I've realized I'm not wearing glasses because I can't see that, so give me... So, mostly exhausted. You know, without glasses, that looked like great. So, maybe I should take the glasses off because then I can think everyone's doing great. Okay. I promise in 3 weeks, things will get better because you would have finished your exams and you'll have a proper break to just reflect on what you've learned. So, finished the maths lab test. Now you're in for the fun. In for the fun. Okay, let's just then do some questions. Let's just do questions. I think I'm also overcooked. I've overcooked myself trying to make questions. Then I decided to change an exam. Let's just not even talk about it. Let's just do exam questions. Okay. So lecture code Bree shared. Again, the My Experience surveys. Please fill them out. We do use the feedback very much from them, and we make sure to kind of use that feedback to improve the course every term or every year, depending on what the improvement is. So we really do use the feedback, but remember to keep the feedback constructive. Always constructive for all your feedback when you give feedback to anyone in life. It's just a life advice because people are a lot more likely to take it on board. Okay, find the range. Oh, and Bree, she's so on top of things. Yes, online classes, please. If you're in an online class next week on Monday or Friday, please register for another lab so that we can check that you're all good on the exam interface so that you can get in and you can do your exam on exam day with no problems, because it's very stressful when something is not working and you've sat down to do the exam. We really want to avoid that. Okay. What are we doing for the public holiday lecture on Monday? We are chilling. We're not having a lecture. We're really just enjoying a day of doing an assignment and many other assignments. So you really... it's a day off, and that means there is no lecture that time. Probably from this point on, we're not learning anything new. It's just revision and practicing. We tried to leave a few lectures at the end to go over and bring things together so that there is time to reflect on things as well. Because part of learning is also doing that kind of reflection. What are my gaps? What do I need to learn? So we really just want to do a lot of that. Oh, I love that. The week 10 practice exams is in your lab time. So it's whenever your normal lab is, that's when you are sitting that practice exam. So, there's nothing special about it. We don't ask you to make any special time for it. The help sessions are not running on public holidays, but they are running around the public holidays. So I think the Saturday has help sessions. Bree, sorry, can you look that up? I'm sure you're already doing that, but just in case you're not, thank you. But there is nothing on Good Friday, and there's nothing on Easter Monday. I think, from memory. We don't put them on, and not on Sunday, but there is stuff on Saturday. Do come to the help sessions if you need help with the assignment or with anything else, okay? Please, please, please make sure to come to the help sessions. Okay, today, even if it rains, I'm at uni, so maybe the internet is safe, but that is not really, after week 1, that's not really a given. That's just, we hope for the best. All right, let's do our first question. Okay, find the range, the difference between the biggest term and the smallest term of a linked list. Okay, excellent. You see, I went crazy this morning. I've way too many questions. Oh, you can't see. Oh, well, that's probably good for you that you can't see, because you'll freak out when you see this. No, now I'm doing the wrong. I tell you what, I'm being killed by my, it was just doing the wrong thing, and now it's gone. Oh, my screens are completely swapped over. Okay, even my computer is done with life, so it's overcooked. The computer's overcooked. Okay, here we are. Is that tiny? There we go. Beautiful. Okay, all right. Let's keep it undercooked, not overcooked. Okay, fantastic. So now you can see I have gone crazy this morning. I was like, I don't know how many questions we'll get through. Maybe we'll get through, I don't know, 10 questions, but apparently maybe more. But let's just kind of go through, and we'll jump around, I think, a little bit, and I'll increase them in difficulty as well, just so that we can practice a few different things as we go. So lots of votes for linked lists. I'm going to put it out there that people do worse on the array hurdle questions in the exam than they do on the linked list ones. Just putting it out there, because linked lists are a lot more methodical. So even if you don't understand what you're doing, half the time you can get the first hurdle out just from following some similar patterns. Okay, let's do it. Which one was I doing? Range. Okay, which one was the range? Range.c. So let's open up our first question, and even better, let me give you access to it so you can see it as well. Okay, excellent. So what does this, that's why I wanted this to be the first problem. I kind of wanted to set it out like you will see it in the actual exam. So obviously it's not going to be like this in your code, but this is kind of what the text will look like. I wanted you to see that it's very similar to the way we're going to do the labs as well, and the way that we have been doing the labs, okay? So you're going to see this find range. It takes one parameter, a pointer to the head of the list to search through. Find range should return a single integer, the difference between the smallest value and the largest value in the list. So for example, if the list contained 3, 4, 5, 6, then it will return 6 minus 3 is equal to 3. If the list contained not wine, oh my God, that was quite a slip. If the list contained 1, then the find range should return 1, as it's the only value in the list. Testing, it will contain a main function which allows you to test your find range function, which I showed you before. And basically what the main function does is it converts the command line arguments to a linked list, and you do not change it. Then it will give you a little test to show you what the output will be for the different inputs. And it will give you your assumptions, restrictions, and clarifications. So exactly the same as your labs do. This is going to look very similar to that. So it's going to tell you exactly what we don't want you to do and the things that we do want you to do. Okay, so if we start this question, any ideas of what we're going to do? How are we going to solve it? So we've got some struct node here, the definition, and then we have the function that we're going to be changing right here. So any ideas, suggestions? And now the delay is going to kill me, I know, but what are your thoughts on how we approach solving this question? Yep, I like that. So we want to have 2 variables, one for smallest and one for largest value. and we want to loop through and find min and max. Yep, perfect. We have to traverse the list. Perfect, perfect, perfect. And someone said if we have to check for if it's null, check if the list is empty. So null and initialize both to the first node. Yes, I love it. I love it. I love it. I love it. Excellent. Okay. That's really, really good. Everyone's doing really well. Don't worry if you're doing well. I'll increase the difficulty. Okay, so let's do it. So the first thing we want to do is we want to check if the list is empty. Yeah. So we will check if head is equal to null, which will tell us if the list is empty. And if the list is empty, we need to return 0 because there is no range. Okay, great. And now we go on to actually talk about all the other things that we want to do. So great, that was our edge case if the list is empty. So now we need our two variables. So we'll have in smallest and in largest. And we want to, so that's the other thing you can do. You can, if you would like, write helper functions if you want in the exam. You don't have to, right? You can do it all in this function, or you can write helper functions as well if you want. So just to, I guess, demonstrate, I'm going to do some helper functions, okay? So I'm going to do a find smallest and I'm going to do a find largest helper function. Just to show you that you can, or you can do it all in one, up to you how you do the code. You're not marked on style. We don't care if it's, you know, looking a little bit messy in there. Doesn't matter. So you're not going to be, you know, and no one's counting how many lines you have, etc., etc. And then our range will be largest minus smallest. But when we do it like that, when we do in the main like that, and this is the whole point of functions, is we can really break up this logic into what's going on. So we kind of just did exactly what we, you know, said here. We kind of checked if it's empty, then we found the smallest, found the largest, and then we returned the largest minus the smallest. So without actually going into the code itself, we've used this big function to really detail how we're going to solve our problem. And so now we just do those little helper functions. So, and you don't need to, if you're in the exam, you don't need to write any comments, you don't need any headers, you don't need anything like that, okay? You can just code. But remember, still make it neat. So we have one that's going to find the minimal value. And the first thing we're going to do is we're going to set our current node, we're going to set it to head to be able to traverse our list. And then I'm going to make the smallest value, as someone said before as well, I'm going to set it to the first element in the list. So I'm going to set it to the current data. Okay, now that I have that, I'm ready to loop through the list. How will I loop through the list? Will I go all the way through the list, or will I stop at the last node? What do we reckon we... All the way. Yes, absolutely. Whole list, because I want to check if the last item is small as well. So if we're going all the way, we're going to go until current is not equal to null. And then we move it along, and we want to find if whatever is sitting inside my current data is in fact smaller than smallest. And if it is, then my smallest is going to be equal to current data. Otherwise, I just keep it moving along. Yep. Okay, so fantastic. I think that shall do it. Except no, that shall not do it. Forgotten one thing to do, and that is a return value, because it's returning the smallest value. So then I'll return the smallest when I'm finished. Okay, so someone said, don't you also have to check if the list is empty? So I check that at the very first step. So I check if the list is empty before I call the helper functions. And only if it's not empty, that's when I'll go and find the smallest and the largest. But absolutely, you should always check if the list is empty. Because if it is empty, that is an edge case that we need to take care of first. Okay, fantastic. We've now found the smallest, so now let's find the largest. It's going to be a very similar function, except that it's going to be looking for the largest thing. So this one, everything in it, the logic is the same, except over here instead of less than, it's going to be greater than. And then yes, and yes, I will need to check the case where potentially something, and we will test it, absolutely. Got largest, 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 and we return largest. Could I have not chosen better names? Okay, excellent. Let's try it out. Let's see if it's going to work for us. So DCC, what's the function? Range.c. Okay, so compiling, do we compile? We're thinking about it. We do not compile. What's wrong? Can someone tell me what this error means? I could have predicted I would have made this error before I even made it. I don't know why I just talked with my mouth full of water. Yep, no prototype, exactly. So my usual favorite thing to do. Perfect, good. Look at you guys, knowing what the errors means. Fantastic, music to my ears. All right, let's save it. Let's run it again. And we have success. So now let's run it and let's do a list. Okay, so what should I test it with? Talk to me. Give me some things to test it with. What list will I test it with if I had no order tests available to me? Okay, first empty. Let's do an empty list. I like it. And the range is 0. So perfect. It's working as we want it to. A single node. Okay, let's do one node and the range is 0. Not really working for a single node, is it? Okay, great. And then let's do multiple nodes. So let's do 1, 2, 3, 4. So that should return 3. That's working. What else should we do? And then we should just maybe, should we do 2? Oh, that was a disaster. So it's not working for one node because let's do 4 and 2. 2 nodes is fine. And then also they are in reversed order. Okay. And what about if I have my biggest value in the middle of the list and the smallest value in the middle of the list? So I'll go 5, 6, and 3. Okay, and the range is 5, which is 6 minus 1. So that's working. So what's not working is when it's got only one value in the list. And so if we go back to the spec, we have if the list contained, it should return 1 as it's the only value in the list. Okay, fantastic. So where do you think is this issue where we're basically not being able to do much? Where is the issue happening where we are not, where it's giving us 0? Yeah, oh, someone's already answered it. Sorry, human being is answering it. It's because when we do our find the largest, we set it to the current data and nothing happens in here, so we return the largest. And the same thing with the smallest. So when it gets to this point here, it basically says, okay, 43 minus 43 or whatever the numbers are is equal to 0, right? So we're not taking care of that one case where it might be not quite working because there's one item in there. Okay, so we could take care of it here just as an edge case. So we can say else if head next is equal to null. So, and what do you reckon I should do? Let's go, think fast, think on your feet. Well, you're probably all sitting down. Else or else if? I don't know. I love the honesty. Okay. So if head next is equal to null, that means that there is only one item in the list. So this means only one item in the list. And yeah, in that case, why not? I can just return my whatever's inside the head. Yeah. So the head data. And that's it. Yeah. Okay. Let's try it out. Let's see what it does for us. Compile it. Run it with many things. Don't know why I ran it with many things. Let's run it with one thing. And it's working. Yeah. We can also check, is smallest equal to largest? And if it is, then just, you know, don't subtract them from each other. So we can do that. I just dripped on myself. Okay, there we go. That was only a few minutes and we've got one thing down. Okay, excellent. Let's do another one. Whew, what fun, what fun, what fun. Another linked list. Should we do a hard linked list, a harder linked list, or an easier linked list? Let's do... People want a 3 dot, a 2 dot, no, not a 3 dot. I'll go, let's do a 2 dot. This would be a question of the first hurdle. Okay, this one would be a second hurdle, okay? Second linked list hurdle, the one that we're doing right now, this insert order, this would be like a second hurdle. Okay, so what have we got? We've got a linked list and the task is to insert a new node into a sorted linked list, maintaining the sorted order. So if my list was 3, 7, 10, 16 and I want to insert 8, the 8 would need to go somewhere in here in the middle between 7 and 10 for it to become 3, 7, 8, 10, 16. Okay, again, I have my strings to list and my print list and I will print out the new list to make sure that it's all working, right? And I'm taking the list again off the command line. Okay, does that make sense as a spec? Make sense for the spec? And if it does make sense, what do you think we're going to start doing for this node? Okay, so what do you reckon we need to do to do the insertion of a node in a sorted order? What do we reckon? Yeah, so we need to move through the list and we need to check what the next one is. Is it bigger than the one that we want to insert? Then we want to insert it. We do need to malloc the node that we want to insert in, and we need to be able to create a node. So the series of things that we want to do is we really want to create a node to insert. We want to check if the list is empty. And if it is, insert at the head of the list, yeah? Which is also really the tail of the list. It's the everything of the list. Okay, great. We want to, so we've done the empty list. What else do we want to do? We want to check something else. We want to traverse through the list. And do you think it would be useful in this case to keep track of a previous and a current node or just a current node? What do you reckon in this case? What do we want to keep track of? So because I will want to know, I will only know whether to insert when I get to 10, right? I'll show you why. Let's have a quick diagram of why that is the case. I mean, a few people seem to understand, but let's not assume. So if we have, oh my gosh. 3, 7, 10, 16. I'll just go with the same one. Okay, so our list is 3, 7, 10, 16. And we want to insert the node 8. So we're going to compare 8 to 3 and say, is it big? Is it smaller than 3? Is it smaller than 3? Sorry. Oh my God. Is 8 smaller than 3? No, it's not. So we're going to keep going. Is 7 smaller than 8? No, it's not. So is 8 smaller than 7? Oh my goodness. My words today. Is 8 smaller than 7? No, it's not. So we're going to keep going. Is 8 smaller than 10? Yes, it is, which means that we want to insert beforehand. So we want to keep track of a previous node and the next node of the current node, because otherwise we will lose track of where we are. And we'll go through the code in a second after we write it. Okay, traverse through the list and track previous and current. And edge cases to consider, which we will consider in a second. Okay, so let's do a few of these things just so that we can get a little bit of code started. And let's do our 2 nodes to track where we are at. So we'll do current is equal to head, and we will have a previous node. And the previous node we're going to assign null to because it's standing before the current. So it's standing right at the beginning of the list where there's nothing there before the beginning of the list. Okay, excellent. So the first thing we're going to do is we really need to know if the list is empty. If the list is empty, then we can insert this node at the head. But that means that I need something to insert if I find out that the node, that the list is empty. So the first thing I really want to do is I want to create the node for inserting. So create the node first. That will be inserted into the list. Okay, so we should be super familiar with this structure now. So struct node, new node. We're going to call up malloc and we're going to ask it to give us some size of a struct node. So we're going to malloc some memory, create a new node, and then we're going to initialize that node. So we're going to give it some values. So new node, the data is going to be equal to, and let's see, so we've sent it in with this number, which means that the new data is going to be equals to number, and then the new node next is going to be null. So we've just created a node that's kind of hanging on its own. It's not connected to anything yet. Okay, but it's there, it's ready to be inserted. So the next thing that we're going to do is we are going to actually check if the list is empty and insert it at the head. Okay, so if we're to look at what we've done right now we have this list over here. And what we've done right now is in our current code, we've said struct node current is equal to head. So we have said that this is current over here. And then what else we did is we said that the previous is sitting prior to that. So the previous is sitting a little bit here. It's currently just over here in space. It's equal to null. It's not assigned to anything right now. Oh my gosh, I'm tripping myself out with this. Okay, excellent. And then what we did is we used this to create the new node. So we malloc some space, some memory space to create the node, and then we assigned it the data, for example, 8 that we want to assign to it, and then we basically kept it empty. It's sitting on its own. It's not pointing to anything. Okay, excellent. So then what I want to do is I want to start checking where I need to insert this node. So the first thing, I'm going to check if the list is empty, because if the list is empty, I'm just going to make this node the head node, okay? So to check that the list is empty, I'm going to basically check if my current is equal to null. And if it is, then that means the head of the list is now going to point to the new node that I've created. So the head of the list is now going to have the address of the new node. And remember, the head is just the address of the first node in the list. So now it's going to contain the address of the new node. And then I'm going to return the head because I've just changed the head of the list. Okay. That means I'm now ready to start inserting. So this was our first edge. Excellent. Okay, so now we're going to traverse through this list. And remember, the list is 3, 7, 10, and 16, and we're inserting the 8 through it. So we want to know where to insert 8 into the list. For example, this is just an example list, right? If only I could type it, that would be really amazing as well. Okay, so we need to traverse the list, which means that we need a loop. And what are we going to loop here? What do we reckon? Are we going to go through the whole list? Are we going to stop at something? Do we need to stop at the last node, or do we not need to stop at the last node? Why do you think that is? What do we reckon? But I have the previous node, so I don't really need to stop at the last node because I've got the previous telling me what the previous one is, if that makes sense. So that means because I won't need it, I have the previous, I can go through the whole list. Yeah. Okay. So I want to keep going through the list until I reach a second condition, which is where I find a place that I need to insert my my node. Yeah. So I'm going to check where if current is not equal to null, which keeps me going through the list. And I'm also going to check when I get to a place that the number is greater, the first number that is greater than my inserted number. Okay, does that make sense? We'll go through it in a second with code. It is harder sometimes to understand it in when it's just spoken. Okay, so we're looking for two things to be true. We're looking that our current is not equal to null, which loops us through, traverses us through the whole list. And I'm also looking to check whether each node, the data in each node is less than the number. Okay, and if it is, then I'm going to move my list along. And so when I come out of the list and I want to move two things, I want to make my previous current, and then my current I want to be current next. So that will keep me looping along until I get to potentially the right node. So when I exit this loop over here, what it means is, so when I exit the loop, either I have reached the end of the list, so I've met the first condition, or I'm standing at the place where I need to insert. Okay, so what we're doing here is basically this with these conditions. So if I go here and I start checking, my first line of code here will be, okay, is current equals to null? No, it's not, because there's a node here. And then the next thing, is current data, so this value here, is it less than number? Is 3 less than 8? Yes, it is. So that means I'm going to move my previous to current. So my previous is going to go over here, and my current is going to step to the next one. So my current is going to move over here, and I'm going to loop again. So is current not equal to null? That is correct. Current has a node, so it's not equal to null. And is the data in that current less than number? So if is 7 less than 8? Yes, it is, which means it's true. So I enter the loop again and I go again. So my previous is going to move along by 1. And then my current is going to move to the next one as well. So my current is going to move over to the next node. So the current is going to be standing on the next node. So then I'll go into the loop again and check the conditions again. So is current not equal to null? That's still true because it's 10, there's a node there. And then I'll check, is the data inside my current node, is it less than number? So is 10 less than 8? This is not true, which means that I exit this loop. And when I exit this loop, that means I'm standing at this position. I'm standing, this is my current node, and this one here is my previous node. So I'm ready to insert between the two nodes. So what I want to do is I want to go from my previous node, I want to connect to the new node, and from my new node, I want to connect to my current node. Okay? Yep, so I'll explain it again in a second. Let me do the connection and then I will explain that condition again. And that condition only works if the list is sorted, right? So if the list is in order, ascending order, when it's going up, descending is going down, right? Someone, I think it's ascending order, from smallest to largest. Thank you. Those two always kill me. Thank you. Okay, so basically what we're doing is we are looping, we're going through, that second condition checks whether, because if the numbers are sorted, then the first time I reach a number bigger than the number that I need to insert the first time, that means I need to insert it right before that number. Yeah? So I will keep looping whilst my number is greater than the numbers in the list, because I know that the first time that condition is not true, that my number, so this 8, is not greater than 10, that's when I know I've gone too far and now I need to insert after the previous node. So just let me know if that's not clear still. Okay, so now let's do our connections. So here we are, we're ready to make some new connections. So what we want to do is we want to go our previous next. Oh my gosh. Previous next is going, so from previous next, I want to go to the new node. So it's going to go to the new node, and my new node next is going to go to the current node. And I'm going to return the head. Okay, there is a way that this might be broken. Okay. Let's see how you would test this code, okay? And let's see if we can break it. How does that sound? So if we compile it, what should I test it with? Talk to me. What should I test it with? Let's test it with an empty list. Yeah. So empty list. Things are not going well for us for an empty list. Okay, great. Empty list is a bit of a disaster. Oh, that's why. Because give me a second. It's because I forgot to specify which number we're inserting. So let's say we're going to empty list. I want to insert the number 3. Okay, it's inserted it. That's working for us. Okay, so empty list is okay. I was like, we took care of that. That would be really awkward if that didn't work. Okay, now we're saying only one data in the list. I like it. So if we have that and we want to insert after that one piece of data. So my list is 3 and I want to insert after it. Okay, that's working. What about if I go backwards? If I've got 3, but I want to insert, that's going to be a disaster. That's not going to work for us. Yeah. So we've just struck disaster for that. And many data in the list. Let's check it for many data. 3, 4, 6, 8. And I want to insert somewhere in the middle of it. No problem. And let's try inserting at the tail. Yeah. Always try at the head. So the tail works. The middle works. The empty list works. But the head does not work. If I need to insert at the head, it's not working. Yeah. So remember this for your exams. At the head, at the tail, in the middle, empty list, okay? If that's the only thing you learn, that will be, no, you need to learn a little bit more than that. But yeah, a simple if to fix it, okay? So if we have come out of this loop, okay, and you can see that this error happens because my previous next is null, right? It means I want to insert when previous is still null. So that's what I want to check. I want to check if my previous is equal to null, because that will tell me that I actually haven't moved. I need to insert at the head of the list. And if my previous is equal to null, that means that this node has to connect to the head of the list, and this has to become the new head of the list. So what we're going to do is that my new node next is going to point to the head of the list, and the head is going to become the new node. So that will take care of that. And then otherwise, I will just do a normal insert if it's in the middle. And Bree or John, are you able to do polls, or is it just me that can do polls? Okay, so let's compile it again. Would have been really helpful to save it. Let's compile it. And let's try it again now. Let's try it with those things that were not working before. So if we insert in the middle, no problem, okay? If we insert at the tail, no problem again. If we insert at the head, yes, it is working, okay? And if we go empty list, it is working as well. So now we've got a fully functioning code that works. So Bree, can you should we do a diagram on the full functioning code for all the edge cases or not? Thank you. Or you feel free to put in the chat. I don't know how everyone is feeling. The poll just seems sometimes the easier way to get people to. One person said no and then came back and then said yes. Ah, 50-50, what a breakdown. You're killing me. Oh, that's ridiculous. It's not a 60-40. The diagrams are winning. It's going to be a landslide. Let's do them quickly, then we'll have a little break, okay? So, it's like watching, I don't watch the F1, but this is quite exciting, isn't it? We can do a string problem next, which is more closer to a 3-dot. We absolutely can. Yeah, some people are just tuning out of this lecture potentially. I don't know why. This is the most excitement you will ever have, solving problems, inserting nodes. Amazing, amazing, amazing. I'm wasting time now. So let's just quickly run through it and not waste time. Okay, so I kind of started going through it with the list and we inserted into the list. What happens if we now take care of the edge cases? So basically what is happening if the list looks something like this? So if the list is 9, 10, 11, and I still want to insert the number 8, okay? So if this is the case and this is one of them and this is one of these exciting edge cases that you have to take care of, that's when you insert at the head. We can see that 8 is now the smallest number in this list, and it will need to go at the head of the list. So what happens then? Again, we assign the current to the head of the list. So the current is over here, and our previous is over here. So it is currently sitting with null over here. Great. So I'm going to make a new node, which is this node over here. I've already made it. I'm incredible. I do things before the code even gets to it. Let's pretend that that's not the case. Okay. We check if current is equal to null. It's not null, there's a node there, so I don't need to go through that if statement. Now I'm going to check this condition. Current is not equal to null, that is true. So this current is not equal to null is true, so I need this one to be true as well to go into the loop. And this part of the condition is saying, okay, current data, so is 9 less than 10? Okay. Where did I get 10 from? Who knows, right? I can't believe no one's pulled me up on that. I'm clearly off with the fairies. Is 9, I'm like, that doesn't work. Yeah, because it's completely wrong. Okay, so is 9 less than 8? No, 9 is not less than 8. This is false, which means we don't go into this loop. So when we exited out of this loop, and before we had this if statement, when we said previous next, it meant that we tried to dereference a null pointer, which is why it was a mistake. So now we're taking care of this case where we would have to insert at the head of the list by checking if previous is equal to null. And if we check this previous is equal to null, it means that we are checking whether or not we will need to insert at the head. So if it is equal to null, which in our case it is, then what we're going to go in here and we're going to say new node next. So from my new node, next instead of null is now going to point to the head of the list, which is here. And the head of the list is now going to be at new node. So I'm now going to assign my head to be this. So when I return the head, I'm now returning the new head of the list over here, which will be able to breeze through the list. Yeah, does that sound good? Oh, people are talking about the race. How exciting. All right, fantastic. So let's take a 5-minute break. We'll come back, we'll Kahoot, and then we will also do a strings problem, which is like 3 dots and is going to cook you up. I don't really know how to turn myself off, so I'm just going to turn my camera off. I don't have the thing to make. I don't have a we'll be back shortly, so you just get to enjoy 5 minutes off the lecture code. But maybe in the chat you can pop down, how you doing? someone's got a Kahoot struct there. Oh, I've got fans. Yes. Someone's being cooked. Just wait till you see the strings question. Sleepy? We'll wake you right up soon. I can like, yeah. All right, let us begin. Some of these names. Are we done? We cooked, we're starting. Just a small collection of participants today. I did another very cooked Kahoot, so sorry. Yay! I also have really good names. Second last Kahoot. Whoa, not bad. Not bad, not bad. Okay. Just a little sum of all of them. All of them, yep. Okay. Next. Who's on top? Ooh, I don't know how to say that. Full stop is on top. Here we go. Next one. Whoa, we're killing it. I'm killing you, we're killing it. Whoa. Okay, freeing is, oh, not much practice. Maybe we should do a deletion one. But I promise strings. Alan! I've got to find that meme of the Alan, the meerkats. That's my favorite. What's the output of the following code snippet? Good luck. May the force be with you. I made this one longer. Someone who writes a Kahoot question and is running out of ideas. That's who. Woo! runtime error. Why do you think it's a runtime error? Who can tell me? Who can tell me? We're going to hit a 10 when we do this first, because I is equal to 9. So it's going to go in here and it's going to do I plus 1, which is going to give the 10th reference. So it's going to be an out of bounds array, because even though the array has 10, the size of it, there's only, remember the indexing starts at 0. So there's only, the last index is the 9th index. All right, let's see who's back. D-Dog, winner. I like that winner, and someone who's cooked is doing quite well. Just checking your strings. Clearly not biased in the, ooh, interesting. So I did string copy and I copied the second string into the first one, and then I printed out the first, which is given me rules. D-Doug still on top. Oh, well, nothing's really changed in these first three. Sarah coming in hot, right on the heels. Is it because of me? Am I in the way? Am I the problem? Okay, I don't remember what the code was. We have a runtime error. And why do we have a runtime error in this one? What do we think? What do we reckon? Why we got a little runtime error? Yeah, string 2 is too long. String 1 was too short. So we're out of bounds. Ba-bum. Winner! I love it when irony comes to life. Actually, that's not irony. This is just truth-seeking. Winner is the winner. Is this the Kahoot winner from yesterday? I wonder. Whoa, okay, kind of okay. All right, you got a function main, you declare a variable y, it's 20, then you send it to the fun with 20, you go to 20, it's copied into here, x is equal to 30, great, but you don't ever send anything back, so then you print out y, and you're going to print out 20, woohoo! Winner, still on top. Next up, question 7. Giving your brain a chance to relax. Oh, kind of woohoo. Almost. It is a runtime error because you will compile, but then when you try and dereference that null pointer, you're going to have some issues because you're dereferencing. Oh, winners moved one down. D-Doug back on top. Cannot be beaten. No, it'll still compile, but it will have a runtime error. Whoa, not bad. Well done, team. Well done. You've got this array. You're going to send something to the function change, and you're going to send it the address at the second index, so 0, 1, 2. You're going to send it the address where 3 is sitting. You're going to go in here, and you're going to dereference that 3 multiplied by 2, giving you 6, and then you're going to add it to the variable at the address, so it's 6. So when you print it out, you're going to print out a 6. Woohoo! Winner, back on top. It's a very tight race up there. Quick little brain relax for this question. Woohoo! Well done. Oh, cannot be beaten. Let's see. Oh, I like this. I like seeing this. This is nice. Okay, climb high. Sasha's the best. Climb high. Okay, next one. 10 out of 11. What a nightmare. Well done-ish. So at some point, because you're going to access something that is going to be out of bounds. All right, let's do the next one. The next one. Who's the winner? Still the winner is the winner. Is this the last question? Yes. Last question. Whoa. Whoa, whoa, whoa. Spread thin. Okay. So we've got freeing the list, current is equal to head, checking for head is equal to null, returning nothing. Then whilst current next is not equal to null, we are going to do some things, but when is going to be ow. Sorry, I was weirdly sitting on a chair. Which line could first cause access memory after freeing? Okay. Do we see why that one or not? How are we feeling? Do we see why? Why not? Maybe, maybe not. Hold up. It was so badly written. I'm so sorry. I just want to keep things, keep things real for those that are guessing as well. I want to keep them in the game. I don't really understand this question either right now. Let's give it a minute. Let's see who is, let's have a look. Okay, let's go through it. Okay. So we've got whilst current next is not equal to null, strike node temp is current is equal to current next. Aha, we've moved our current along and then we free the temp. Yeah, so then which line? Yeah, so then this current next is going to be the first time that we're going to access something that's, okay, let's just keep cooking here. Things are going well for us. Number 3 is the skull face, going well for this person. Oh, we're not lost at probably at that last question, which didn't make any English sense. Good job. Oh, D-Doug made it all the way to the top. Final moment. Unfortunately, don't have any chocolates to give through the screen, so well done. I think that's D-Doug. Douglas is D-Doug, right? Is it? Maybe. Yeah, look at that. Okay, and now look at this. All right, actually, Bree, can I get you to do a poll that asks if we want to do a strings question or if we want to do a delete node question now? Yes, there's the Sasha's the best, amazing. We've got an intruder, amazing. Delete node, string, both. Someone needs to get that, the girl with when she's choosing whether to have soft tacos or hard shells, and she's like, why not both? Why not both? Which one first though, Bree? So many questions. Why'd you do this to me? The first one will be, thank you, Bree knows exactly what I'm talking about. The first thing we're going to have to do is we're going to have to delete the node whilst we're in a linked list mood. And then we will go to strings. And then if we don't finish the string, then we will finish it next week. How does that sound? Oh, both simultaneously. I don't know if I can do that. I'm not that good. Not on a Tuesday in week 9. Maybe if you'd gotten me in week 2. Yes? No? People want the string, but it's a close call with the delete node. A node that has a string in it. I need to plan that question. Yeah, okay, fine. Let's do one delete and then we will move on to strings and then it's perfection. Chef's kiss. Okay, let's do this one. Delete. And what was it called? Delete. Delete duplicate, delete 6, one of those. Let's see what this one is. Delete the first instance of a duplicate in the list. How does everyone feel about that question? Would you like to try this one? Or the other one is delete the first node that's divisible by 6. If there's no nodes that are divisible by 6, you should return the list unchanged. What are we feeling? Delete 6 or delete duplicate? Which one? How are we feeling? You're right. Delete duplicate is more annoying. So of course you're going to choose that one. Yeah. Good chat. Okay, let's do it. Let's do delete duplicate. And if we don't get to a string today, do not worry, we will do a string. Okay, let's delete duplicate. It is harder, so let's go through it and then maybe you can, over the long weekend, you can just have a good time. Try delete 6 and then I can solve it for you anyway on a video or anything like that. Okay. Yay! We've got the same thing we always have, this strings to list function, which is going to take in and give us a list and we don't have to worry about it. Yay! This is not a 3 dot, this is a 2 dot. The strings question will be a 3 dot. So this is going to be a second hurdle, which would be a delete. This would be 2 dot question. Okay, so what do we need to do with this one? We need to delete a duplicate. No, you cannot use arrays. You can only use a list for this one. Definitely no arrays. Okay, how are we going to solve it? What are we going to do? What are some edge cases? Talk to me, talk to me, talk to me. Throw me some stuff. Throw me some stuff. No one's throwing me anything. Empty list. Yes. Check for empty list. What else? If I have one item in the list in this case, that's not going to have a duplicate, is it? So I need to also think about a single node list, because that's not going to be a duplicate. That's just going to be one unique thing. Yeah? Okay, great. Then I'm going to go through and I'm going to try and search for something that is a duplicate. So I'm going to traverse the list and look for a duplicate to delete. Okay, so note here that we do make the question easier, okay, and we only ask you to delete the first instance of it, not every instance of a duplicate. You can then try at home to do every instance of a duplicate, which means you keep the loop going, right? So let's talk about it. So people, do we use a previous and a current for this one as well? When you're deleting, it's, quite useful to keep track of both, because then when you find the node that you want to delete, when you're on the currently standing on it, you really want to have information about the previous node. So you really do want to keep a previous and a current node going. Okay, let's do it. Let's do the edge case first. So easiest thing to do is we're going to check if head is equal to null. And then the second edge case, for both of them, we're going to return the same thing. Or if my head next is equal to null. So that's checking for a one node linked list. Yeah. I'm going to return the head. Okay, because that's still returning null if it's this. And then if in this case, if it's head next, then it will return whatever the item is in the head. Okay, excellent. So if we have the list, the first instance will be the 2 after the 1. Sorry, no, the 2 after the 3. Sorry, so it's going to be, okay, probably a good idea to say what the clarification is. So if the list is 1, 2, 4, 3, 2, 1, 2, okay, you're going to traverse and you're going to say, okay, this is unique, this is unique, this is unique, this is unique, this is no longer unique, I've had a 2, so I'm going to delete this 2, okay? So it's like the first instance after the original, yeah. So this is the one that I want to delete over here. Yeah, so this is what I'm trying to also show you, these 2 dot questions and the hurdle. It's a second hurdle in the exam. They're not going to be like every possible case. You got to do everything under the sun. There's going to be restrictions placed on it so that you're able to do it. Remember that the exam is only 3 hours and we really are very conscious of that. But sometimes, so yeah, we are very conscious of the timing. Okay, so let's do it. I'm going to have a struct node current and I'm going to make it equal to the head. Amazing. I mean, you couldn't have anything else like this. Or should we do it the opposite way? How should we do it? We could change it to make it a harder question. Or we could just make it an easier question to start with, then make it a harder question. Let's just wing it. Let's just wing it as we go. Okay. And I'm going to take a previous, I'm going to spell correctly. And I'm going to have a previous node. Okay, and then I'm going to do some traversing. And in my loop, I'm going to check, I'm going to go through every node and I'm going to check what's going on, whether or not that duplicate exists. Okay. So what do I want to be doing here? What do we reckon? What do we reckon? What code should we think about writing? Just going to be, I'm just going to do this just because always set up your loop so then, you know, it's there for you. Yeah, I do want another loop to keep track of what's going on. And I'm going to have something in this loop as well. It is a nasty nested while loop. It will be. Okay, so I think we should draw a diagram for those that are playing along at home and don't have a clue what's going on right now and how they're meant to know what code we're going to do. So my pen's gone off, so let's switch my pen back on and let's draw a little diagram. So let's say I've got a list and the list is 3, 4, 5, 4, null. Okay, excellent. So what I want to be able to do is I want to be able to loop through the list till I get to this one, say, yep, it's a duplicate. And so I'm going to have to delete this node if I can. Okay, so if I have a current pointer here, what I need to do, okay, if we think about it, I can't just compare it to the one after it, okay? Because if I move the, well, I can compare it to the one after it, but then if I move it along, if I do my usual loop and I move the current along to this one, what will happen is that I'm only ever comparing two nodes. I'm only ever comparing the two nodes next to each other if I compare this one and the one next to it. But what I want to be doing is I actually want to be taking, okay, if I've got my first value, what I want to do, and I'm standing at this current over here, so I'm standing at current, I want to be able to compare it to every single item in this list. So is this a duplicate of it? Is this a duplicate of it? Is this a duplicate of it? No, it's not. So if none of them are duplicates after I've reached the end, then I want to move my current along, yeah, to go here, and then I want to go again. Is this a duplicate? Is this a duplicate? Aha, I found a duplicate. So now I can stop and I can actually delete it. Okay, so this is where this nested looping is coming from, because I have to go first one, go through the whole thing, go to the second one, go through the whole thing, go to the third one, go through the whole thing, and so on and so forth. Okay, so does that make sense? How are we feeling about that? With my dirty arrows that don't, that all kind of intercept each other. So what I'm going to do is I'm going to now make another node. And my other node is going to be, so what I'm trying to do now is I'm going to say, okay, my current is standing over here. And I'm ready to start comparing them. So my other node is going to be over here. Yeah. And then I'm going to compare, I'm going to move the other node along to be able to compare it. Yeah. So now what I'm going to do is I'm going to check in the second place, and we're going to keep completing this code. Okay. I'm going to check that my other is not equal to null, because that's what's going to get me from this one moving along until it gets to the null, to the end of the list. Okay, so I'm going to check whether or not this other one gets to there. And as I do that, did not mean to do that, was meant to be on this line, I'm going to check if it's a duplicate. So if whatever is sitting in this other data is equal to whatever is sitting in my current data, then that means I have a duplicate and I want to be able to delete it. Okay, so then I'm going to perform some deletion and I'm going to return the head of the list. So let's see what we would need to do if we are deleting. Okay, someone's called delete node function, yes, but you don't have that function available for you. So let's say that I've reached this over here and I need to delete it now. So my other would be standing over here, and I need to delete this node. My current is still over here. So how do I delete this node when I don't know where this node is over here? Do you see the problem that we have now? So we really need to be also tracking the previous node as well in our inner loop, so that we are able to make a connection when we're deleting. So in my inner loop, I'm also now going to keep track of a previous node. and that previous node is going to be standing at the current. Yeah. So if I'm standing at the other over here, then my previous is standing at the current. So this is also going to be my previous. And I'm not going to have the previous over here right now because that's not looking, I don't need it to be keeping track of these nodes. I need it to be on the inside loop. Okay, so I've got this. So that means that when I get to this point here, this one should be my previous node. And what that means is I can now kind of do the deletion. So what I want to do is if I delete this one, then what I want to be doing is I want my previous to connect to my other next. And then I want to free that other one. Yeah. So let's put that in code. So we want a temp node to hold some stuff whilst we do some deletion. And the temp node is going to hold my other next. So whatever is sitting in my the next node. So after I have the temp, I'm going to hook up my previous next to the temp. So to whatever's sitting in this other next. And I'm going to free the other node. And I'm going to return the head of the list. Okay, now if my other did not match it, so if this data was not correct, so if the duplicate, if I didn't find the duplicate, then what I want to do is I just want to move my nodes along. So my previous is going to be the other, and my other is going to go to other next. Okay, so maybe this is going to work, maybe not, who knows. Probably shouldn't return a null here. Let's return the head of the list. And let's try it out. Let's try it out. Let's see what it does. So we got DCC. Great, 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 great. The most common mistake you can make. Done it. Okay. Oh, I'm sorry. I forgot to give it a name. Okay, let's do 3, 4, 5, 4. And it's deleted the 4. Okay. What should I try now? What should I try now? And then I'll go back to the code to see what we can break. Oh, well, that was painful. 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7. Okay, that's working. One node. Yep, that's good. Let's do the edge cases. So one node will just return the list unchanged. Empty list. Empty list unchanged. Yep, to have it in the middle. Oh, that deleted the wrong one. Oh no, it didn't. The first one. Yes, the first duplicate. Yep. List with no duplicates. Yep. 3, 4, 5, 6. Yep, unchanged. Three, 4, 3, 4. 3, 4, 4, 3, 4. Okay, so that's doing it. Does 3, 4, 5, 3, 4, 5, 4, 3? It does, even though, because it's deleting the first duplicate, and the first duplicate is the 3. Yeah. I know, it threw me as well. I was like, why isn't it deleting the 4? We've just been deleting 4s all around the place. Okay, how's everyone feeling about deleting nodes? Bree? Sorry, Paul? Negatives? Sure, let's do negatives. Minus 3, minus 4, minus 5, minus 3. Minus 3, minus 4, minus 5. Yes. No. So it's a harder question to delete all duplicates. It's an easier question to just delete the first instance of a duplicate, which is why it's only doing the first instance. Haha, how can we rewrite it so it deletes the first instance of a duplicate number? What a lovely question. I'm going to leave you to try it and then I'm going to answer it, just so that we have time to do a little bit of string today, and also so that you get a chance to play around and break the code. There is nothing better than breaking things. No, the first duplicate is 3. So because 3 is the first number, so the first duplicate you meet is going to be the duplicate of the 3. All right. The spec would be super clear about it. These are questions that I made up as I was trying to push certain agenda into questions. The spec would be super duper clear. You're not going to have these kinds of questions in the exam. They're going to be well defined. So like that first question I did, they're going to be well defined. They're going to have clarifications and they're going to have all the edge cases covered. We do multiple run-throughs of the exam to make sure that we don't miss any edge cases. These are just for funsies to do in the lecture and to kind of wing it a little bit and to discuss things. No, probably don't. Yeah. Okay. Check out this string that I've got 2 string questions actually. Oh, I haven't even made it. Okay, so 2 string questions, and the 2 string questions are, actually there's one that's called isogram and there's one that's called substring. I'll open both of them and you tell me which one you want to do. Okay, who knows what an isogram is? I was fascinated by this definition when I was looking for special words. Isogram is a word in which no letter of the alphabet occurs more than once. Write a C program that reads in words until Control D and checks whether the word is an isogram. That's your first choice. And then your second choice is also ugly. Substring. Write a C program that reads in words until Control D and checks whether a word read in as a command line argument appears in the main word. If it appears, print it again. Another excellent spec right over here. And we could do one next week, so don't worry. But which one would you like to start with? I kind of want to start with isogram. Yeah. I reckon isogram's a bit easier to start with. Yeah, in the exam you can write helper functions outside of the given function stub and call those in the given stub. Yeah, substrings are really painful. I have two questions that let you practice it. There's an array sum, like a subarray sum, and there's a substring. So we can do some of those. We can do both of those questions on Tuesday. Let's do isogram then. Isogram, yay. Okay. All right, what do we remember about strings? And you know what? Since people are asking about helper functions, I'm going to write a helper function in here as well. I'm going to do a helper function that's going to check if something is an isogram. It has letters. Amazing definition for a string. It does have letters. It also has something else. Yes, and a null terminator. That is the special thing about strings in C. and it is very special, is that there is a null terminator telling us when that string has ended. And that's really important because otherwise we would not know, because strings are arrays of char in C. Okay, helper function to find out if something, an isogram, not even something, a word is. Okay, let's do it. So let's go through the first part of the question, okay? So in the first part, so we have write a zebra that reads in words until Control D and checks whether the word is an isogram. So the first thing we need to be able to do is we need to read in some words until Control D and check if isogram. So to read in the words, who remembers what we're using to read in words? What function do we use to read in strings? Anyone? 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 What is the function that we use to read in strings? Please tell me you remember. How long is this delay? This is awful for me. I feel like no one knows anything about strings. I don't know how. This is now the university delay. What got censored? Who got censored? What's being censored? Why would anyone censor me? Oh, okay. F gets. I mean, it's not even, that's not a swear words. Why would that get censored? Is that getting censored? That's so weird. Okay, you're right. The function is F gets. I didn't realize. So that was an awkward situation there, wasn't it? You can't write it. A super awkward situation. Amazing. I'm like, oh my God, no one knows how to read in a string. Back to the drawing board. We need to go back. Okay. If we're reading in until Control D is pressed, that means we're going to put our F gets into the while loop. Yep. And we're going to keep checking whether or not everything is happening in it. Until nothing is happening in it. And how do we tell that? Null. So when it returns null, that's when it's all over and there's no more words to read. Okay, so that's when we move on. Okay, what does F gets need? F gets need the array into which it is reading something. So we kind of need that array. So let's make that array. We're going to have char word array and we're going to give it the max size, which is hash defined over here. Yep. So we need the array that we're reading into, we need the size of the array that we're reading into, and we need to tell it where to read in from. For you guys, not a problem, still standard input, nothing else, but when you move on, you can also read from other places. How have I got an extra bracket? I'm going insane. There we go. So this while loop will let us read in until Control D is pressed, and then we want to be doing something. So for now, if I enter in a word, okay, I will then press enter after it. Yeah. So I really want to be able to remove that new line from my word, right? Everyone happy with that? I'll just wait till you tell me if you're happy with that. Then I'm going to want to check if something is an isogram, and I'm going to send that word to it. And if it is an isogram, I don't know, this would be defined in the question, okay? So if it's an isogram, for now, I'm just going to print out This is an isogram. Amazing. Creative thinking there. And otherwise, if it's not an isogram, then I will print out that it's not an isogram. Okay, amazing. So the only thing that is left for us to do is to remove that new line so that we can, so we can have a word without that beautiful new line at the end, which gets read in as well. So what I'm going to do is I'm going to take the word, I'm going to take the string length of it, and I'm going to go back one space so that I'm in the array still, and instead of that new line, I'm going to override it with a null terminator. Okay, so this is me getting rid of a new line. Okay, so I'm going to read in a word, I'm going to get rid of the new line, so I'm going to null terminate where it is, and then I'm going to take that word and I'm going to send it off to my helper function, which is going to check if it's an isogram. And if it is an isogram, it will print out that, and if it's not, then it will not print that. Now that is correct. I'm like, too many brackets, not enough brackets, somewhat enough brackets. I know, FGATS is not like I don't feel like it's offensive, but I could be wrong. Okay, so now is the piece de resistance. We need that function that actually does the thing that we want to do, which is check whether or not each letter is unique. Yeah? Okay, so we're going to return an int, so we'll return 1 if it is an isogram, and we'll return 0 if it's not an isogram. So I'll have a function, and that function is going to receive a char word with some size in it. And okay, let's do it. So ideas of how we're going to do this. How we're going to check. How are we? I love that the FGATS has been such a passionate discussion. But how are we going to check here whether or not every letter is unique? There's many ways to do it, by the way. It's not just one way to do it. It is similar. The strategy is kind of similar to what we did in the duplicate number in linked list. I agree. I suggest for us to have an array in which we're going to keep track of what's going on. So I'm going to have an array of 26, right? Because there's 26 characters in the English alphabet. So I'm going to keep track inside here of whether or not, something has occurred, and then add it in there. You would nest a loop. You could nest a loop. I would do a loop for sure. It's not possible in this case because I'm going to press enter after every word to say that the word has finished. Okay. Okay, so I guess we're rolling. Okay, I'm going to declare a little increment, an incrementer that I'm going to play along with. And then I'm going to start checking my array at index I. And whilst it's not at the end, so to check whether or not I'm at the end of the word, I'm going to check whether or not it's reached the null terminator. So this loop will allow me to go through the word until the end. So for example, if I have the word, I don't know, I guess we're playing with FGATS. Let's do FGATS. So if I have the word FGATS, I'm going to have it, it's going to be FGETS, and then there's going to be the null terminator at the end as well. So I'm going to have these characters here. So this loop allows me to loop through till I get to the end of one word. So now I want to check for a few things. Okay, So what are some things that we need to maybe consider? And the question would be better worded. I'm going to, first of all, assume that all the letters are the same, right? So I'm going to assume that it's all letters for now, and then we can talk about how to do it if it's not letters. Or should we just consider, okay, let's consider the case where the letter is capital or lowercase. Is that a repeat? I should have done that assumption. And okay, so we'll consider the case where the letter is a capital or lowercase. I think it's a repeat because it's still the same letter. And, oh, bye. Oh no, it's 55, it's 5 minutes too. I'm going to have to finish this lecture. But we can continue this on Tuesday, so don't stress, we will solve it. Is this a good time to finish? I don't know. The pressure. Let's do one more thing. We've got 1 more minute. Okay, so if I'm considering that each letter is going to be, if it's a capital and it's a lowercase, that's still the same letter. I'm considering them to be the same. So what I'm going to do is I'm going to move everything to a lowercase. So in your exam, you're going to be, oh, everyone's feeling cooked. Maybe we will finish, but I'll just say this. In the exam, the question will specifically say, do not use these functions. Do not use like string.h, for example, or something. It will tell you specifically not to use certain libraries. If it does not say, do not use this library, feel free to use whatever library you want, right? So we're going to pretend this question hasn't told me not to use string.h. So I am going to use string.h, and I'm going to use it to convert a character to lowercase. So I'm going to take that character, whatever it is at word I, and I'm going to use toLower to convert it to a lowercase character. Okay, so what that will do is it'll take care of this case over here where it's an uppercase and a lowercase letter. Okay, excellent. So now I want to make sure that I'm only doing it for alphabetic characters. So if my character is alphabetic and I'm going to use another string.h function, which is alpha, I'm going to check that that character is an alphabetic character. And if it is, then I'm going to do something where I check whether or not it has repeated or it hasn't repeated. Okay, so I'm going to leave it there, so because it looks like a few people have been cooked, and this is getting into the logic, so I want to draw it out. So I don't want to have logic without being able to draw a diagram and show you how it's actually working. So let's finish up there for today. Thank you so much for today. I'll see you all on Tuesday online. It's going to be a great lecture. We'll do another string, and we'll do, feel free to, leave a comment of what else you want to do. I think we were going to do divisible by 6 or something like that. We can do a few other questions as well. But try and break the duplicate one to do many duplicates, and yeah. All right. Good luck for the rest of the week. I know it's really intense, but it's happening. Thank you, everyone.